Hi, in this video I'm going to cover the topics about volume that is covered under P5 and P6. Okay, this is a long video. I will start off with the introduction of what is volume, and I will go through the various concepts that your child will be required to understand in order to solve the problem sum in the workbook as well as the past year paper. Okay, so let's begin. So first thing is that your child need to understand what is the difference between a cube and a cuboid. Okay. So when the question says that the object is a cube, it simply means that the dimension of this object on the three sides is the same. That means the length, the breadth, and the height is exactly the same. So when the question says it's a 10 centimeter cube, it simply means that the length, the breadth, and the height of this cube is 10 centimeter. But when the question says that it is a cuboid, it simply means that it's a rectangular object. So which means that the length, the breadth, and the height may not be the same. Sometimes the question will say that, okay, this is a cuboid with a square base of 5 centimeter. So it means that for this base here, it's actually 5 centimeter by 5 centimeter, but the height could be another figures. So if your child didn't understand what is the meaning of a cuboid and a square base, they will not be able to do the problem sum. Next, what is the volume? Okay, so in P5 they learned that given an object, if you want to find the volume of this object, okay, the example given is that you have a 1 centimeter cube. So remember, we just learned that 1 centimeter cube means that it's 1 centimeter by 1 centimeter by 1 centimeter height. Okay, and you try to arrange all the 1 centimeter cube into the objects. So in this case, for the length, I can arrange 5, 1, 2, 3, 4, 5 cubes. For the height, I also can arrange 1, 2, 3, 4, 5 cubes. And for the breadth, I can arrange 4 cubes. So the volume of these objects is actually the number of 1 centimeter cube. In this case, I got 5 cube, and 4 cube. So if you look at it, since the side of the cube is 1 centimeter, so it's 1, 2, 3, 4, 5. So it's 5 centimeter by 5 centimeter by 4 centimeter. So total, the volume of this object is 100 centimeter cube. Okay, so the volume of this object is 100 centimeter cube. So if the question asks in one of the workbook, they say that okay, this object is already have the cubes inside. How many additional cubes that you can put in? So the way to do it is to find the volume of this object itself, which is 100 centimeter cube, and you find the number of existing cubes that is already inside here, and you subtract away, and that should be the answer. Okay. So as you go on to P6 or P5 after this topic, you realize that volume is simply using mathematical formula of length times breadth times height. So the length, the breadth, and the height. Okay, whether you call this length or you call this length is the same. Basically what you're interested in is the area of this portion multiplied by the height. Or sometimes you just put L times B times H. Another important concept that your child needs to know is what is a base. Okay, so remember we say that the volume of an object is length times breadth times height, or L times B times H. Okay, so in times the question will always say that oh, it has a base of how many centimeters square. What does that mean? Okay, the base means is basically the bottom piece here. So it actually comprises of only the breadth and the length. So if you say the base is 10 centimeters square, it simply means the length and the breadth of this object here multiplied together is 10 centimeters square. Hence, once you know the base on the object, you just multiply by the height. That will give you the volume. So if you know the base, you multiply by the height, you will give you the volume. Why? Because base is length times breadth. So now, sometimes the question do change a bit and they trick you. Okay, so we already know that base is equal, volume is equal to base times height will give you this volume. Okay, so I take the base times the height. But sometimes the questions will give you the area of one side and ask you to find the volume. So if your child is confused and think that, oh, I don't have the base, I cannot find the volume, then he is not correct, because if you just flip the cube clockwise, this side is actually looks like the base. So once you get this side here, multiply by the length here, you will still get the volume. So similarly, if you have one of the surface area here, you multiply by the depth here, you also get the same volume. So it never change. Just tell your child that, okay, if you cannot visualize, take a cube and just flip it and put this at the bottom. It will look exactly the same as here. Same thing for this cube. If you flip it towards you once, it will also look the same as the base here. Okay, next. So what is the meaning when the question says, when the tank is completely filled, 50% filled, or 1/5 filled? Okay, so you need to understand this concept. So number one, let's assuming that we have a tank that is completely filled. So the dimension of this tank is 10 centimeter by 10 centimeter by 10 centimeter. So when this tank is completely filled with water, assuming, okay, it simply means that inside this cube, it contains 1000 centimeter cube of water, because it's completely filled. That means it's totally filled. Okay. When the question says that the tank is half filled, or if you have learned percentage, they sometimes say that it's 50% filled. What it means, it simply means that if the height is 10, half of the height is 5 centimeter. So it simply means that the height is 5 centimeter, or 50% of 10 is 5 centimeter. So the volume of water in this tank now is 10 times 10 times 5, because the volume of water is the height of the water here. So it's only 500 centimeter cube, which is half filled, which is correct, because when it's completely filled it's 1000, when it's half filled is 500. So because the worksheet questions and the workbook question as well as the exam question will also test you concepts of fractions, percentage together with volume, instead of giving you nice number of 2 centimeter and so on, they can tell you that it's 1/5 filled or 20% filled. So the same thing, if the question says that it's 1/5 filled, you simply take 1/5 multiplied by the height. Okay, so in this case, 1/5 of 10 centimeter is 2 centimeter, or 20% of 10 centimeter is 2 centimeter. So the volume of water is 10 times 10. In this case, you multiply by 2 centimeter is 20 centimeter cube. So although the tank is 1000 centimeter cube, but the volume of water is only 200 centimeter cube. Next. Okay. This is another type of question that they will ask you. They say that now you have a completely filled or fully filled tank, and you pour some water up, or you scoop some water out, okay, of the tank, and they ask you to find what is the new height. So based on the previous slides, we already know that a fully filled tank for this object is 100 centimeter cube. Okay, I purposely put here to show you that the base, in this case this orange color part, is 10 times 10 is 100 centimeters square. So this base is 100 centimeters square. Okay. So assuming the question says that, oh, somebody pour out 20 centimeter cube, 200 centimeter cube of water from the tank. Ask you, what is the height of the water now? So the way to do it is quite straightforward. Okay, you already know that the completely filled tank is 1000 centimeter cube. You remove away 200 centimeter cube. So the amount of water that is in the tank now is 800 centimeter cube. So now you know the volume. You want to find the height. So remember, we say that the volume is equal to the base times the height. But since now we know the volume, we know the base, we can find the height. So the height is simply taking the volume divided by the base. So the volume is 800 divided by the base of 100. I get 8 centimeter, which means the height is 8 centimeter here of water. Okay, so that's explain why just now I go through the concept of volume is equal to base times height, because that will simplify a lot of things for your kids. So for the same question, assuming this time they increase the amount of water, they say that, oh, we pour out 600 centimeter cube. Same thing, you get 1000 when it's fully filled. You subtract 600 centimeter cube, you remain with 400 centimeter cube. So the new volume is 400. The base remain unchanged because it's the same container, so it's still 100. The new height is 4 centimeter. So this is how you find out the height of water in the tank when they pour out some of the liquid. Okay. Next, this is another type of question that will likely to appear or commonly appear, is that water is transferred from one tank to another and they ask you to find the height of water in the other new tank. So we use the same example. We have this tank that is 1000 centimeter cube. Okay, we already know the base is 100 centimeter square. Okay, so this is 1000 centimeter cube. Now the question says that, okay, you empty this whole tank into a new container, another container, and this container is 10 centimeter by 25 centimeter. They didn't tell you the height. They just say that the base is 10 centimeter by 25 centimeter. And they ask you what is the height of the water in this new container, assuming 1000 centimeter cube is poured into here. So the first thing you need to know is that you need to find the base of this new container. I just call it new base. So it's 10 centimeter by 25 centimeter is 250 centimeter square. So remember, area is square because it's only centimeter multiplied by centimeter. There's only two of them, so it's centimeter square. So the base is 250 centimeter square. We know the volume of water remain unchanged, so which means that you still have 1000 centimeter cube of water that's poured in. So you get 1000 divided by the base. So remember, you have to find the height, you just take the volume, divide by the base. So 1000 divided by 250 centimeters square, you get 4 centimeter. So the height of the water in this new tank is 4 centimeter. So in the original tank is 10 centimeter, but in the new tank is 4 centimeter. Why? Because the base here is only 100 centimeter square, whereas the base here is bigger, is 250 centimeter square. So of course, the water level will be lower. Next. This is another type of question that will be frequently asked, is that same as the previous one, water is transferred from one tank to another, but this time around they say that, oh, the height, that means you don't transfer 1000 centimeter cube of water over. You pour the water into the new tank such that they will have the same height. So you do not know how much water was being poured, but what you want to get finally was you want to have the same height. So how do we do it? Okay, so the way to do it is quite straightforward. First, you need to know the volume of water. So in this case, the volume of water is 1000 centimeter cube. So which means that this blue color part plus this blue color part still 1000 centimeter cube, no change. The only way, the next thing that you need to do is to find the base area of the first container and the base area of the second container. So the base area of the first container is 10 times 10. The base area of second container is 10 times 30, which will give you a total, you sum them out together, is 400 centimeter cube. So 10 times 10 is 100, 10 times 30 is 300, you sum out is 400. Same thing, now all you need to do is take the volume divided by the total base. So you take 1000 divided by the total base is 2.5. So the trick to solve this type of question that you want to get equal height is this. Step 1, find the total volume of water. Step 2, find the base of each integer container. Add the base area together. Then you get the volume divided by the total base, and that will give you the common height. I have a video that explains in another format talking about how you distribute money across two classes of students. I will share with you later which video to watch. That will give you a very layman explanation in case you cannot visualize. Okay, so I repeat, what you need to do is take the total base and take the volume, divide by the total base, and you can get the common height. Next, water is transferred from one tank to another that already contains with water. So same thing, we have this container A and this container B. Now the difference between container A and container B is that in the previous question is that the container B already contains some water inside there, and it contains 4 centimeter of water. Okay, 4 centimeter in terms of height. Okay, so they ask you, okay, if I pour container A and empty into container B, what is the new height and what is the volume of water in container B? Okay, so I repeat, container B already got some water, you empty container A, everything into it, and of course you will add on. So they want you to find the new volume and the new height in container B. First thing, how to solve is that you find the volume of container A, which we know is 1000 centimeter cube, 10 times 10 times 10. We find the volume of water in container B, which is 10 times 40 times 4, which is 1600 centimeter cube. Okay, so now container A is empty, everything go into. So what is the volume of water in container B? Is basically container A plus container B. So you take 1000 plus 1600, you give you 2600 centimeter cube. So inside this tank got 2600 centimeter cube of water. To find the height, you divide by the base of container B, which is 400 because it's 10 times 40 is 400. You take the amount of water is 2006 divided by 400, you get 6.5 centimeter. So the height of this water here is 6.5 centimeter. So you notice the way to do is the same as the previous one. Just always take the volume, divide by the height. Next, water is transferred from one tank to another tank that is contained with water. And they want you to find the common height. So you have a fully filled tank. Oh, I forget to put the color. So this is a fully filled tank, assuming that it's full of water. Okay, and you're going to pour it into container B. Okay, so you're going to take this tank and pour everything into container B. But same as previous, you do not pour all the water over, but instead you want to make sure that they have the same height. So remember, this is not empty tank, this is a fully filled tank. I miss out the coloring. Okay, this is a fully filled tank. You pour some water over here such that they have the same height. So same thing, what we do is that we get the volume of water in container A, which is 1000 centimeter cube. The base is very important. It's 10 times 10 is 100 centimeters square. The volume of container B in terms of water is 1600 centimeter cube. The base is 10 times 40, so it's 400 centimeters square. Okay, so first thing, you want to find the total volume of water. So total volume of water is volume A plus volume B. So it's 1000 plus 2600 centimeter cube. So the total of volume of water in these two containers is 2600 centimeter cube. Now you want to find the common height. Remember what we learned just now? To find the common height, all you need is to get the total base, which is base of container A plus base of container B. So the total base is 400 plus 100 is 500. So we take the volume, divide by 500 is 5.2 centimeter. We can now say that the height here is 5.2 centimeter. So you see the way to do the question, the steps is always the same. It's just that whether they already have some existing water that you add in, or it's an empty container that doesn't contain existing water. Okay? So I think when you reach P6, you will start to have problems where they have volumes of objects that make out of two cuboids. So remember, when we say cuboids, it simply means that the length, the breadth, and the height could be different. So if you see an object like that, and they ask you, please find the volume of this object. Okay, the way to do it is just treat these two objects as two separate objects. Okay, don't be confused by just because they are joined together, but just treat them as two separate objects. So you find volume A, which is 10 centimeter by 5 centimeter by 4. So 10 by 5 by 4 is 200 centimeter cube. Volume B is simply 2 centimeter by 2 centimeter by 5 centimeter. In this case, it's a square base. Okay, so I forget to put it, but it's a square base. So it's 2 centimeter by 2 centimeter by 5 centimeter is 20 centimeter cube. Okay, so the volume of this object is simply volume A plus volume B, which is 200 plus 20 is 220 centimeter cube. Okay, once you find the volume of the object, now they makes the question a bit more challenging. They tells you that somebody pour in water into this container and ask you find what is the height. So assuming for this round they pour in 100 centimeter cube of water into the container and ask you find what is the height. Okay, first thing you need to understand the concept is that when water is poured into a container, the water will sink below. It cannot be floating. So the water will sink right below. So which means that he will fill from below and slowly come out. Okay. So we calculated, or if it has not been calculated, you calculate the volume of container A, you realize that it's 200 centimeter cube. Container B is 20 centimeter cube. If somebody is pouring 100 centimeter cube of water into the container, okay, it simply means that it cannot even fill up container A. Okay, so the water did not even fill up container A. So in this case, we can ignore container B totally because you have a container that is volume 200 centimeters cube. Sorry, it should be cube here and it should be cube here. Apologize. Okay, so it should be cube, it should be cube. Okay, so 100 centimeter cube of water trying to go fill up 200 centimeter cube of water is not possible. Okay, so in this case we can ignore volume of B. So which means that all we need is to use the base of container A to find the height. So same thing, the base of container A is 10 times 5 is 50 centimeter cube. So the height is basically taking the volume of water divided by the base, which gives you 2 centimeter. You notice this concept keep repeating. Okay, so you take the volume of water divided by the base, you get the height. Okay, we move on. Same thing because I copy and paste. So this should be cube, this should be cube. I apologize for that. Now, assuming that they pour in 200 centimeter cube of water into the container. So if you already know the volume is 200, and this is 200, which means that it's exactly the height of container A. That means it fill up to the brim of container A, but nothing go to container B. So by default, the volume of water is equal to volume of container A, so which means that the height is 4 centimeter. You don't even need to calculate because it's already here. Okay. Third scenario. Now they pour in 210 centimeter cube of water into the container. So same thing, we know container A 200, container B 20. So now since they're going to pour in 210, which means that it's more than container A. So which means that container is filled up and some water go into container B. Okay? And they want you to find the height of water in container B. Okay? Not the whole container, not from here, but only the container B. So you take volume of water, in container B is volume of water, which is 210, minus container A, which is 200, which is 10 centimeter cube, which means that the volume of water inside here is 10 centimeter cube. So you take volume of water divided by the base, which is in this case 2 times 2 is a square base. So 2 times 2 is 4. So 10 divided by 4 is 2.5 centimeter. So the 2.5 centimeter here. In case the question asks you the total height, that means from all the floor to here, then all you need is to add the 4 centimeter. So 2.5 plus 4 is 6.5 centimeter. So you need to be very clear what the question asks. Is it this height or is it the total height from the base? Okay. I've covered all the type of question that is asked in question paper and workbook. Okay. There are other information to take note. Okay. The question sometimes instead of putting 1000 centimeter cube, they tells you that the container contain 1 liter, 1.5 liter, and so on. Just your child need to know that 1 liter is equal to 1000 centimeter cube. So before he can do any problem sum, he need to convert all the liter to centimeter cube. So 1 liter is 1000, 2 liter is 2000, 1.5 liter is simply 1500 centimeter cube. Next, instead of telling you the volume of water in the container, they can actually add in a little bit of complication by saying that, for example, you take this question, water from a tap is flowed at the rate of 1500 centimeter cube per minute into an empty tank. Okay, so it simply means that if you turn on the tap for one minute, it will contain 1500 centimeter cube. If you turn on 2 minutes, it will be 3000 centimeter cube. Turn on 10 minutes, it is 15,000 centimeter cube. So that's simply what it means. Instead of telling you that, oh, what is the volume of water inside, but they give you as a tap. So don't be confused, but simply knows that that's how it works. Okay. If you find this useful, I actually already has a video that's previously created. This is the P5 workbook question. You can go in and take a look. How you search for this question, there's 2 ways. You can go to the YouTube playlist and you look for geometry, all the geometry type of question is inside there. I also have the P6 workbook question that I previously created. This is the one that I actually explain why common height can be found by taking equal base. Okay, I created an example inside of using a classroom distribution of money so that the kid may be able to understand better. Okay, this is the one that they use the volume of water. In this case, they call it the oil. They use 2.6 liter. So 2.6 liter simply means that it's 2,600 centimeter cube. So you need to convert everything to centimeter cube. And lastly, I know that it's sometimes difficult to find questions in the YouTube itself. I do have a Google site. You can go in, you click on the topic that you're interested in. The whole list of questions is inside there, and in each question there is a link that link you to the YouTube. So I have a video on how to use this Google site. You can actually find in the playlist as well. Okay, I hope this video is useful to you, and if you find my video is useful, I appreciate you can subscribe it or give a thumbs up so that will motivate me to create more videos. Thank you very much.